Hi, this is Matthew Wang. Thanks for tuning in to PyGotham 2021. And today I'm going to be talking to you about data quality. Specifically, we're going to talk about data quality as it relates to building out your ETL pipelines and how we can use automated testing in order to make sure that we're building out robust infrastructure. So data quality is definitely not the sexiest topic of the data domain. I like to think about it as the workhorse of data in that doesn't get as much attention as, say, a show pony. But super important for carrying your goods up the proverbial data mountain or building out your pipelines. So I'm going to start with a scenario that many of us are familiar with, which is how we build out a typical ETL pipeline. So it involves gathering data, possibly from multiple data sets. So we may need to join our data sets together. We'll usually conduct some sort of transformation of that information. And we might repeat that process. So there might be other data that we end up joining in or filtering out. We might do multiple transformations, and then eventually we'll load our data into a reporting infrastructure. So that could be a data warehouse. Once we're good with that, we'll ship it off to another team. So it could be the data science team that ends up doing some modeling. It could be the analytics team that builds out dashboards. And so we think that it's good. We ship it to production. One of the problems that might arise is that those downstream users might recognize that there's a data quality issue, so their models aren't producing the results that they would expect, or they just notice something funky in the results that are outputted. And so that might be handed off back to our team, where we might need to debug and find out what the actual issue is. So this is a simplified scenario. At each of these steps, there could be a failure point. But as you might know, ETL pipelines can get really complex. You could have dozens, if not hundreds, of different data sources. There can be many different transformations that occur. And so it can be rather difficult to debug, especially if it's something that we're not necessarily familiar with. So lots of cost to this poor data quality. We may only notice a couple of these, but that's just the tip of the iceberg. So outside of our company, there could be a poor consumer experience. Say we're Netflix, we end up thinking that our customer hasn't paid its bill, but they actually have. That could lead to a loss of brand trust and frustration and reputation for our company. Similarly, for internal consumers of that data, they might be making poor business decisions. It's a pretty time-consuming and frustrating to debug those sorts of issues if it's a complicated pipeline. And because developers are spending their time on it, it's also going to cost the company money. So the question that we're really trying to ask is, how do we optimize our time as engineers and minimize the cost for both the company and consumers of that data? So we think about our ETL pipeline with multiple failure points. What we can do is sort of change this. So we still have all of our steps, but we can add in testing, right? So each of our steps, say we're gathering data, between this step and joining our data sets, we're actually checking the assumptions that we're making and making sure that not only for this joining step, but also for transformation and loading data, that we're validating that the outputs actually look like what they should. And if we repeat this process when building out our ETL pipeline, we'll eventually ship it to production. And hopefully in that process, because we've done all these validations in a very meticulous way, should be shipping out less mistakes every time that we do a handoff to our end users. So I think it's always helpful to go through an example to drive this point home. So we think about our ETL pipeline and the first step, which is gathering and joining our data. For this particular example, I'll work with provider information, providers for healthcare, that is. So we're looking at two different data sets. The first is a provider information. So providers are identified by a unique identifier called an NPI. This particular data set has information on, say, provider's phone number, practice information, specialty, What we want to do is join that with payment information. So each provider will conduct a service denoted by another unique identifier called a HCPC code or HCPCS code. And so we have the number of times that that code was serviced for a particular year, and how much they might have charged Medicare or government entity to get reimbursed for that particular service. So we're thinking about what to test for. There's a myriad of things that we could conceivably look out for, lots of different edge cases. So what we really want to do is think about what's core to our business and the problem that we're trying to solve. We can split these tests into two different categories. So infrastructure, what's related to the extraction and loading of our data. So when we're merging data, recasting it, do we still see the same uniqueness for primary keys? Are we introducing nulls? Is the size of our data set what we would expect? Is it coming in on time? And then we can also look at sort of things that are related to business logic. So this is more specific to say the domain that you're working in or the specific data that you're working with, but is it following certain business rules? So if we're working with a percentage, are percentages below 100%, above 0%? If we're looking at means and distributions, do those seem relatively consistent from when our data was run this time versus the previous times? So there are lots of different things that we can test for. What you really want to do is sort of focus in and think about what's important to the particular domain that you're working in. So going back to our example, when we're joining data sets, it might make sense to make sure that we're not introducing duplicates when we're merging our data. I ended up writing a test in unit test, which is a native library to Python, but there are many other libraries available. Specifically for this scenario, it makes sense that for each row, we would have a specific NPI number and then a unique HCPC code. So I ended up writing a test that will check for that assumption. Within the 10,000 rows in this data set, it looks like there's 417 that were found as duplicates. I had this function spit out a sample of the duplicated data. So for this particular NPI, there were two instances of HCPC code 99214. We can further dig into that. I ended up writing a function that will take a specific data frame and spit out what are the columns that have more than one unique value. We look at the columns that were spit out for this particular instance, number of services, number of Medicare beneficiaries, average Medicare allowed amounts. These all seem like either integer or float values. The one that stands out to me is place of service. So when you dig into this, it could be either inpatient flag or outpatient flag. It makes sense that we might have duplicate NPI numbers and HCPC codes and a different place of service depending on where that particular treatment occurred. So whether it occurred in an office setting or an outpatient setting. This was a relatively simple example, but hopefully demonstrates how useful testing can be. Testing is something that can take a bit of resources in order to stand up. But once we do, it's easy to keep going. And over the long run, will end up saving us a lot of time and costs because we're making sure that the infrastructure that we're building, the data that we're putting out there is robust and is clean. So that concludes my talk. Thanks so much for tuning in and enjoy the rest of the conference.